Hi, everyone. For those of you who I haven't met yet, kia ora, my name is Jed. I am a principal consultant at CyberCX, based here in Christchurch. I've been here for like over a decade now, which seems like a long time, but it actually hasn't been that long of a time, I don't feel. And for those of you who may remember my past presentations, they've been a mix of kind of technical and kind of like completely not technical. This is a bit of a everything. So in today's talk, I'm going to take you through a crash course in Golang, the programming language which I've been doing a lot of playing with over the last little while. I'm going to be presenting a novel technique for a C2 framework, something that I don't think I've seen like very much in the wild. And I've got a little bit of Microsoft trolling. I apologize in advance. I know the projector's a little bit blurry, and I'm actually doing this so I don't have to like flick between things because I've got a live demo, and I don't want to like play too much with the demo gods. Hopefully my ping is stabilized. Could whoever is like doing things on the Wi-Fi just like not for the next 20 minutes, please? I don't want to have to like invoke DRBCP because then my demo isn't going to work very well. For those of you who are here, oh geez, it wasn't last year, it was the year before that, and my talk of smartifying your dumb home, you will remember that I have a lot of Raspberry Pis and other bits and pieces floating around my home, and this has only grown in complexity over the last 2 years as well. I'm now up to like 5 of them running around doing various bits and pieces, and that's before I get to all of the Arduinos and ESP8266s that are like taped to the back of my garage door. Fun times. And for those who were paying attention to my presentation, you know, I've got 3 kids. I don't have time to go around and manage a whole bunch of Raspberry Pis. Like, I don't have time for that sort of boring sysadmin-y stuff that I used to love doing back when I was much, much younger and had lots less hair. So I was like, hey, you know, as a busy person, I've got too many devices. I want a way to centrally manage all of these, and I want to have like one unified portal where I don't have to run around or even be at home to be able to apply updates, because of course when it's like, you know, holidays and someone decides to drop a software patch for like your Wi-Fi controller, even though you're not using your Wi-Fi, you feel compelled, right? Like, who here feels compelled to go and patch their home Wi-Fi controller when they're on holiday? No hands. Almost. Okay, some hands, but they're well towards the back so that people don't have to admit it publicly. So basically, like, I want this thing, this sort of agent that I can use to run commands on all these Raspberry Pis. I can get a bunch of files, chuck it up into some sort of cloud-based service with some sort of cloud-based database that I can take out my phone and I can be happy. I can, through a very, very small interface, feel mild panic, and yeah, it kind of makes sense, right? Like, you know, this is the thing. It's 2023. This is what we want to do. So, okay, so to do this, you know, I'm, as Creature said, you know, you should, what is it, adopt, adapt, build? I'm going straight to build. Like, I'm skipping the first 2. All those commercial RMMs, all the open source ones, not good enough for me. I know better. I'm going to build this. So I have to create an app, and I have to create some sort of microservice backend. So I need to be able to get basic system information, you know, what's the uptime, what's the patch levels, I want to be able to like run commands, I want to be able to collect output. You know, this kind of feels like a C2 framework, but it's an RMM, so it's okay. This is an RMM, not a C2 framework. Ignore the title of the talk. And, you know, make sure that I'm doing good operational things. I want to make sure that I have logs. I want to make sure that I'm only allowing connections from certain IP addresses, you know, boring basic bits, because I work with like awesome red teamers at work, and I might not be able to impress them. Like, I can't really hack my way out of a box, but at least I can not disappoint them. You know, I can do the basic things and pretend like I'm an actual security professional. So what am I going to build the agent with? And like, you know, if you've read the title of the talk, you know that I did it in Go. Hey, why did I use Go? Because like, I'm a Python developer. I've been a Python developer for about 10 years. Why am I doing this like weird language? And for actually really good reasons. The first thing is that like, unlike Python, where anyone who's tried to like package up a Python project and then push it across many devices, across different platforms, you know, you've got Raspberry Pis with ARM-HF, and you've got some that are ARM64. I wanted to do none of that. Like, I just wanted this like one binary that I can just put somewhere and download and run. And Go is really good at that. Like, everything is compiled into one nice little binary. Little is sometimes not so little, but little is a relative term. Little compared to the 32 gig of storage that I'm not using on these things. Go is also really good at writing programs that have great parallelism. That's a word and a half, and I nailed it. Yes! Unlike Python, where you kind of have to it does work, and you can do async things, and you can kind of get there. I'll show in the demo that Go just tends itself very, very well to being able to do things like, hey, I want to run a command, so spawn a thread, run the command, send the logs up to somewhere else, do all this in parallel without having to worry about locks, and Jesus, locks are not something that I ever want to have to deal with again. I did that back in Java days. I'm not going back there. Go is not foolproof. I'll show a couple things in the live demo, depending on how much time I kind of have, depending on the demo gods, etc. But there are some things that the learning process can be a bit difficult, and if you can pick up these skills and kind of run with it, you really feel like you're actually learning something. It is really, really cool. And so then I'm coming to okay, so that's the front end. What about the back end? What am I going to build it with? And this is the point where Hillary and Sarah kind of lean in a little bit in the audience. So my day job, I do a lot with Azure. I do a lot with Azure Functions. I would normally reach for Azure Functions, Python, REST, let's go. And I thought, you know what? I could do that. That's kind of boring. I do a lot of that. I've got a lot of functions that do lots of things for me. I want to try something different. Do I go back to legacy technologies, running things on virtual machines or running things in a blockchain? Nah. Legacy technologies aren't fun anymore. I'm going to try and do something else. I'm going to try and use Azure storage blobs as my backend. And the entire audience is like, what the hell is an Azure storage blob? So within Azure, you have a number of primitives. And I think it was one of the first launch ones, was this thing called a storage account. Inside a storage account, this is as basic as it gets. It's bits on a disk or an SSD somewhere, and you have a whole bunch of APIs to get them out again. You can get them out. There's tables, queues, files, and blobs. And in blue there, if you're coming from AWS land, I don't know what any of these products are. I don't know why they have silly names, but apparently those are the equivalents of what you get in a Azure storage account. If you're old man yelling at cloud, that green thing is what you might be used to. So as you can see, I'm going to use Azure Storage blobs. Now, blobs are you create this blob storage, you create a bunch of containers, which are kind of like folders, but not really. Inside these containers, you have a bunch of paths that have these things called block blobs and append blobs. And the difference is that with a block blob, you upload everything all at once. You can, of course, do multi-part uploads and resumable uploads and things like that. Kind of works, but you have to know how big the thing is before you start uploading it. It also has this really cool thing called append blobs, which, if you're old man yelling at cloud, this is something that not a lot of cloud providers seem to have. I don't think there's an S3 equivalent of an append blob. Someone tell me if I'm wrong. I'm not wrong. Awesome. This is really useful if you want to have a log file that constantly gets written to, not having to upload the entire log file every single time. So how do you actually create an API out of something called a blob? Starting at the bottom. So if you think about what it is that your agent needs to do, what are the actual REST APIs that you want to be able to call? There's really only 4 of them. First one is that you want to be able to get some form of control information. Second one, you want to be able to put what your current host state is, what your current running state is. You want to be able to upload logs, so again, streaming all that logging telemetry of what's going on the system so that you can get real-time information back out of it. And when you've gone and run commands on the system, you want to get that output. You want to be able to fetch a file and actually have it go somewhere so that you can interrogate it and use it, etc. That's cool. So those are my basic APIs. The way that I decided to implement this is, okay, so I've got a storage account over in the top half here. Ooh, I can actually use my mouse this time. That's kind of awesome. And I want to be able to give the agent the ability to push and pull from these APIs. But I don't want one agent on this Raspberry Pi over here being able to interfere with this Raspberry Pi over there. So how do I segment that storage account? In Azure, some of you may be familiar with this because there was recently a whole bunch of media coverage about these things called SAS tokens. SAS tokens are glorious. So with a SAS token, what you can do is, based on the storage account's primary key, you can create a delegate key, and you can say, okay, so this delegate key is allowed to read files in this path expiring on this date from these IP addresses, or have an expire years in the future and only write to this path specifically, or anything underneath this container. They are actually quite flexible. And the beautiful thing about them is that I don't actually have to pre-configure them. They're a delegate key based on my storage account master key. So basically, I can create as many of these as I want and not have to go to the Azure portal and not have to pre-create applications. I can do this entirely on my side without telling Microsoft exactly what I'm doing, which, good thing, right? Seriously, Jed, why are you doing this? And I thought about this, and the more I thought about it, the more I liked it, because this is, people talk about no code and serverless architectures. There's no code. This is completely serverless. I'm not maintaining a thing here. I've just created this thing called a storage account. I've got cloud native scalability. I can go from one device to 1 billion devices like that. I don't have a scale set that I have to manage. I don't have to worry about what happens when I want to scale down again. And it's super cost effective. This thing is built in tens of thousands of operations. So as long as I'm not hitting this thing every millisecond, this thing's going to cost me $1 a month to run across all my devices, which is great. Yeah, I went a little crazy. Okay, it happens to the best of us from time to time. Some of us need a pet project. Some of us need a bit of an outlet, and this was my outlet. No, that one. Live demo time now. Make sure the ping is working. The ping is working. Yeah, I'm connected. By the way, so this is a GitHub code space. So this is like a Visual Studio inside the browser, and the remote end is running on this ephemeral machine somewhere up in the cloud. If you haven't played with GitHub code spaces, they're amazing, because you can completely wreck your development environment, and you just delete the thing and start again, and not have to rebuild your entire machine. It's fantastic. If you haven't played with them, go and do that. So I've got this Go application, and what I'm going to do is I'm going to run through the process of creating an agent, so creating the actual config. I'm going to run it up. I'm going to do some things to it. So the first thing I'm going to do is stockpile list. So currently, I have a storage account running up in Azure. It has 3 containers in it, that one, that one, that one. And if I go over to this Azure tab over here, I have the same 3 storage containers over there. So the first thing I'm going to do is stockpile, create, alias, call this one chickon, let's say. Cool. So I've gone, and if I go back over to the Azure side, this is really happening. I'm really invoking demo gods. There it is there. D287 something something something. There we go, D287. I'm going to grab this little snippet of JSON, and I'm going to go and configure it over here. Save the file. So as you can see here, I have a Azure blob, st4cker test, blah, 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 .blob.core.windows.net. Important later. I have the container, which is the GUID of the agent. This SAS token, so everything after the question mark is effectively the SAS token that the agent's going to use. It has an expiry of the 26th of December, so a nice little Boxing Day present for me in next year when this thing just stops working, and I have to run around and find out why it stopped working, because I set an expiry and forgot to set a reminder. I am a typical security person, of course. I actually have the signature here, so this is just a random blob that is derived from my storage account key. Take a picture if you want to play with me. Please don't. Please, hackers, no hacking. This SAS token, I can read, append, create, write, and list files within this path. So this is a SR equals C, means this is a SAS token scoped to the container, so anything under this container, this token is allowed to manipulate it. Okay, I'm going to run this thing up. So I'm going to go and run the agent, and if this all works well, I'm going to get a debug console. It's going to take a second to compile, because of course it's going to take a second to compile. There we go. So right now it has gone to the storage container. It's uploaded a bunch of files. It's set some stuff about its host info. It's waiting on a loop. If we go over to Go, so basically, everything starts at main, as it always does. I've loaded the file in. I've read it out. I've checked to make sure that I actually have a connection string that I can use, etc. I've actually put like the exact same binary as both the agent and the admin. If you're actually building a C2 framework, it's probably not a good idea to put all your admin stuff inside the same binary as your actual implant, but you know, this isn't a C2 framework. This is an RMM tool, right? I've done a bunch of stuff with signals. I've connected to the storage, and I've created an append blob channel. So this is what I was talking about earlier, where I actually have a log file. If I go in to that one and hit the refresh button now, I'll have a log. That log will have like the millisecond timestamp. It's currently got 547 bytes in it. If I go back over here and open up a terminal, I can go stockpile list. I'll see the new one, alias chickon. Hey, there we go there. If I go get alias chickon, I've got a bunch of information. Now, this is running within the actual code space, so it's a Debian. It's got the code space host name there. I've got things like the IP address, the uptime, et cetera, et cetera. Interesting, but boring. If I go stockpile, instead of get, I'm going to tail. So I'm actually going to tail the log file. So this is the exact same as what was being written out to the debug console. Okay, cool. Jed, do something more interesting, please. If I split this window, and again, I'm sorry for the size of the things. I can't see if I can just make this slightly bigger. That just makes it worse, sorry. Okay, if I go over here and I go, okay, so stockpile exec alias chickon command psaux, let's say. So what this has done is this is put in an exec file into the directory, what I have in the main.go. So I've actually got a anonymous go function, which is basically just checking to see if anything else has been read. So if I go to the exec loop, basically every 5 seconds, run this loop command. In this loop command, just see if the control file has actually changed. This is kind of fun. So this is a anonymous Go routine. So this is where you're creating a thread inside the main thread, and you're just saying, yeah, just go and do this thing over here forever, please. Kind of fun. Scope is actually like really hard to control. So in this case, I've had to be quite careful to actually pass in what I want into the anonymous Go function, because funnily enough, like when they first did this, you didn't have to do that. And so you can end up in a situation where, and like the common example is where you have an anonymous Go routine which has like a for loop, and you're accessing a variable outside of that function, and basically everything is just the maximum value because it's actually accessing the global scope. So that's like a trick that you Google for a thing called a closure, and that fixes your problem. But that's like, it's not completely foolproof. Like Go is a nice programming language, but there are kind of hooks like that you just kind of have to be aware of, and knowing what to Google for is part of the problem. Anyway, enough distraction. As you can see, so hey, it uploaded this executable JSON, it then ran psaux, here's a bunch of output. I can do like even more boring things like who am I, but you know, I'm just going to be running as the code space user. I think you get the idea that, hey, and like this is all happening in something called a blob, like right now in real time. Like I'm kind of surprised that this is even, well, no, I'm not surprised this is working. This is of course production quality code. You can totally like go and fork this and do things with it right now, right? Yeah. Back to presentation. One more thing. Hey, so like when I said, you know, this is why I decided to use a storage blob, there was one thing that I didn't completely explain. And that is that if you go and do this and you go and use storage blobs, you don't have to add firewall rules into most environments. I deal with a bunch of customers, some of them more mature than others. Typically speaking, like outbound firewalls are still a thing, and people still configure them. And if you go and you know buy any Microsoft product, like all of you have, and you do have a outbound firewall list to manage, you have a long list of firewall rules that you have to go and add either into your typical firewall or your web content filter or your private access broker. And there's this one firewall rule that just keeps appearing in like every single Microsoft product. If I just enhance that a little bit, just about every single Microsoft product under the sun uses Azure Blob Storage in some way, shape, or form. And so in every single piece of documentation that Microsoft has, they say, hey, yeah, just go and add star.blob.core.windows.net, which, this thing is star.blob.core.windows.net. This fine example is Microsoft 365. This example is Microsoft Defender for Endpoint, Microsoft Power Apps, Microsoft Integration Gateway, Microsoft Azure Stack, Microsoft have a problem with blob storage. And the problem is that it's a very useful platform. Lots of applications need to be able to, have files that they download and files that they upload. SharePoint, OneDrive, built on blob storage, if you didn't know that. You're actually using SAS tokens to access files stored in OneDrive on your machine today. And that can be a bit of a problem, because I also have been pulled into a number of incident response engagements, and when you're in the middle of an incident response, the first thing that you want to do is make sure that the attacker doesn't have access back into the environment, and you typically have to allow some things out. It typically comes down to things like your EDR technology, email, because you actually need to be able to communicate with whoever's just gone and wrecked you. So having a firewall rule that says, yes, you totally need to allow this, and having that as potentially as a C2 channel is not a great thing. And that's it. So my message to you is always be checking. As a security person, please don't take whatever documentation exists and just go and blindly apply it to all of your firewalls. I have tried to raise this to Microsoft people in the past. I get it. E5 licenses are expensive, and discovering what storage accounts you're actually using and what for can be challenging. But please update the documentation and actually give us a list of what blobs are actually Microsoft legitimate and which ones aren't. And I'm 5 minutes early. If you want to follow up on any of this, if you would like a copy of something, hey, here, I'm Jed Laundry at all of the things. And any questions? Or do we play crickets.mp3 for 5 minutes?
Busted!